Hello, welcome back to Advanced Functions, MHF4U1. This is exponential and logarithmic functions. In this lesson number 2, we're going to determine the effects of varying the parameters of a graph of a logarithmic function. So we're going to take a look at all the transformations done to a standard parent logarithmic function. So let's go over some of the rules for transformation of a logarithmic function. So keep in mind the standard transformation functions that we learned it looked like this. Y is equal to negative f k x minus d plus c. So in this case, what we're going to do for f, the function, we're going to plug in logarithmic function. So y is equal to a, it's going to be log to a base of b, and then same thing, k x minus d plus c. Now keep in mind, let's go over some of the letters. So b is the base of logarithmic, or base of inverse of exponential function. Okay. And then we know a. If a is, so we're talking about in terms of absolute value. If a is greater than 1, it's a vertical stretch. If a is in between 0 and 1, it's a vertical compression. But if a is negative, that means it's reflection through the x-axis. If a is outside the logarithm. On the other hand, so that's vertical. Another vertical is c. C, it's a vertical translation. So if c is positive, greater than 0, it's going up. If c is negative, it's going down. And that is, both of them, is the vertical. Then let's go over k. If k, so I'm gonna write down flip first. Okay, flip first. And if k is greater than 1, it's a horizontal stretch. If k is in between 0 and 1, then it's a horizontal compression. It's same thing, but you just have to remember, do the reciprocal for k. And if there's negative right beside k, that means it's a reflection through the y-axis. Another letter that we have to do is D, letter D. For D, you're going to do the opposite sign first. Opposite sign. So right now we see negative D. So if I do the opposite sign, if it's positive D, it's going right. If it's negative D, it's going down. And K and D is the horizontal transformation. Okay. And if you like to use a mapping rule, then the mapping rule looks like this. XY, in this case, it's 1 over K, flip it, and then do the opposite sign for D, and then AY plus C. Okay. Keep in mind, letter B in this case is just telling you what the parent function of the base is going to be. Okay, so this is a review. So the function, which given this time, it looks like this. So I'm using different letters. So A represents what we just did, A. B is the base, capital B representing K, C is representing D, and capital D representing C. Okay? So the reason why I'm using different letters is because I want you to be comfortable looking at the equation even when you're given different letters or different numbers. So this is a transformation from my parent function over here. And the domain is that if B is greater than 0, that means the domain is going to be from C and infinity. And if B is less than 0, okay, that means it's like inverse of exponential decay. That means the domain is going to be negative infinity to where the C is, the horizontal translation. And vertical asymptote is always x is equal to C. Okay. Remember, logarithmic function have vertical asymptote, while exponential function has a horizontal asymptote. Okay, so let's see. State all the transformations done from my parent function y is equal to log 3x and the mapping rule. Okay, now, first thing is look inside the bracket and notice that there's an expression negative x and plus 2. And I don't want anything in front of x. But right now we have negative. So let's factor completely whatever's in front of x. So log to the base of 3. So I'm going to replace my original bracket with square bracket, negative bracket x minus 2 minus 3. Okay, I factored it completely. And now look at all the so the base, my parent function, is y is equal to 3x. So let's see. Let's start with the base function. Y is equal to log 3x. So I would recommend everyone to draw or make a table of values and start with negative 1, 0, 1, 2. So let's plug in negative 1. So if you want, you can plug in log 3 and then plug in negative 1 into a calculator. Or if you want, it's a little bit more extra step. You could do this, make a table of values, and then inverse it, right? You can switch it. But if you have a calculator and you can punch it in, you can go ahead with that as well. Okay? So this wouldn't be like the ideal points because if I were to plug in negative 1, 0, 1, 2, it's going to be 0.3, 1, 3, and 9. So therefore, if I were to switch it, negative 1 goes in the y value. Okay, so ideally, rather than just putting a number like this, I would do inverse. So it will be 0.3, 1, 3, 9, negative 1, 0, 1, 2. Now, after we could do all the transformations together. So for x, there's negative inside the bracket, so look here, negative x, and then opposite sign plus 2. And then for y, it's 2y minus 3. Now keep in mind 3 over here doesn't affect anything in terms of mapping rule. So let's plug in 0.3 into x and negative 1 into y. So 1.7, negative 5, 1, negative 3, negative 1, negative 1, negative 7, and 1. Okay, so what we're going to do is we are going to graph it on the next page. So carry all these points to the next page. So then we know that we do have a, if I were to factor it again, we do have a vertical asymptote at x is equal to 2. So at 2, I'm going to draw a dashed line. This is a line that we're not going to cross. And because it's negative, right, the k is negative, that means my domain can be any real number such that x is going to be smaller than 2 because we have negative k value. And the range y can be any real number. So therefore, let's plug in the points. So when we have 1.7, it's negative 5. 0.7, negative 5. And then 1, negative 3. Negative 1, negative 1. And negative 7, 1. Oops, sorry. Negative 1.7 is negative 5 point. Negative, so it's 1.7 that's giving me negative 5. Oops, this is not right. Okay, and then let's connect the points. It looks like that. And the arrows, don't forget. Okay, good. Now going back, let's write all the transformations. In this case, we have a vertical stretch by a factor of 2. And then we have a reflection. So let's look inside the bracket. So we have a reflection through the y-axis. And that's it. And then we are moving right 2 horizontally and down 3 vertically. And these are all my transformations to my given logarithmic, the base of 3x. Okay, next question. Graph negative log, okay, x minus 3. Okay, so it seems like I don't have to factor anything. Okay, so nothing's in front of x. So again, we know the base is going to be 2. So what I'm going to do is I'm going to think. If I'm getting y is equal to 2x, right, I'm going to do the inverse to logarithmic 2x. So how is that going to look like? Because my original function is going to be negative 1, 0, 1, 2. So it's going to be negative 1, 0, 1, 2. And you do the inverse. So it's going to be 0.5, 1, 2, and 4. Okay. And then let's do all the new everything transformations. So for x, it seems like it's just x plus 3. And for y, it's negative y. That's the mapping rule. And let's plug in all the information. It's going to be 0.5. Now, let's say I did not want to do mapping rule. Okay, so if I did not want to do the mapping rule, you can go from logarithmic form and then reflect through the y-axis and then move to the right 3 steps. Okay, so maybe I can show you that way. Okay, so what we can do is let's draw the logarithmic 2x here. So the vertical asymptote is at 3. X is equal to 3. Okay, because I'm looking at the final one. And so let's say if I'm doing the original one. So original one looks like this. So this is what I'm going to draw right now. And then 0.5 is negative 1, 1 is 0, 2 is 4, 2 is 1, and 4 is 2. So this is my original, y is equal to log to the base of 2x. Now what we can do is we have the transformation. So it's a reflection through the x-axis, and then we're moving right 3 steps. So if I'm doing reflection through the x-axis, I'm changing the y value, right? And moving right step, we're changing the x value. Okay, so as you can see from this table. So what I'm going to do, I'm going to pick a point, let's say 4, 2. I'm going to reflect through the x-axis. I'm going to flip 2 into negative 2. So at 4, it becomes negative 2 here. And I'm flipping it. Just at 2, 1 becomes negative 1 here. This becomes 1, 0 stays the same. Flip this one. This becomes this one. And it looks like this. This is y is equal to negative log 2x. Now finally, what I'm going to do is I'm going to move right by 3 steps. So pick a point again. So 4 and negative 2, we're moving 3 steps to the right. So 1, 2, 3. Same thing, 1, 2, 3. 1, 2, 3. And 1, 2, 3. And there you have it. So we were able to draw, okay, from the asymptote, vertical, draw the transform function from a parent function by doing step-by-step of all the transformations done, rather than doing the mapping rule. So you should be comfortable between both methods, being able to transform from a parent functions or using a mapping rule as well. Okay, next question. So y is equal to 2 log. So now this time the base is 0.5. And then we have x minus 4. So there's no invisible bracket. There's no bracket. That means negative 4 is the vertical translation. Okay, so it makes a huge difference. So look at over here, 2 log 0.5 x minus 4. Do you see the difference? Okay, so if it's in the bracket, it's horizontal translation. But if there's no bracket, that means it's going to be a vertical translation, which is going down 4 steps. So for this one, let's do the logarithmic. So this one, it's coming from y is equal to 1 over 2x graph. Okay, so I'm going to do y is equal to log 0.5x xy. So it's going to be 0. So let's do 0.5, 1, multiple of 2, 2 and 4. So let's plug it in. Negative 2, negative 1, 0, 1. Okay, but if you want, you could do negative 1, negative 1, 0, 1, 2 as well. You can do that as well. Okay, the reason I did not do that is because I just plugged in negative 2 a little bit more because I wanted to get a whole number, okay, which is 4. Now, so let's state all the transformation. So it looks like we have a vertical stretch by factor of 2. And then we are moving right. Oh no, we're not moving right. So we're moving down 4. Okay, so why don't we do step by step this time? Okay, so if I were to do y is equal to 2 log 0.5x, then you're going to do 2y. right? So you're going to multiply 2y. Therefore, it's going to be x stays the same. Then it becomes 2, 0, -2, and -4. And if I were to move to the right step, so finally to log, then it's going to be x 2y minus 4. Okay. So this is the final transform function. So you can just skip to this right away if you like. If I say, if I'm not looking for any steps. So we plug in -4 into this, so -8, -6, -4, and 2. Okay, so let's graph them. So we have a vertical asymptote at 0. And 0.5 is at -2. At 1 is -4. At 2 is -6. And 4 is at -8. And the graph looks like this. So it kind of makes sense because it went down 4 steps and it has been stretched vertically by 2. Next question. So this one, if you take a look, it looks a little bit weird and we have like a number in front. So what I would recommend is to rearrange it. So y is equal to, there's log to the base of 3. So instead of writing x over 2 essentially means it's 1 over 2 x, right? And then we have plus 1. All I did was I rearranged so that 1 goes at the back, and instead of writing x over 2, I write it in a coefficient method. Now, so we can see that the parent function is the base of 3. So let's write down the log 3x, because this is coming from 3x inverse. So it has to be a multiple of 3. So let's do multiple of 3 here. So it's 1. So maybe let's include 0.3. And then 1, 3, 9. And then when I plug it in, it's going to be 2. Logarithm 3 is 1, 0, and it gives me -1.01 approximately. Okay. And then what we can do is, why don't we plug in everything into a mapping rule this time? So we can plug it in. So the transformation's done here. So it looks like k is 1 over 2, so we're going to flip it. So it's 2x, and for y, it's going to be -y plus 1. So let's plug in the points. 0.3 into 2 times, so 0.66. It's 2, 6, and 18. And let's plug it in. So it's negative, negative becomes positive. So it's 2.01, 1, 0, and -1. Okay, now we have a vertical asymptote at x equals 0. And let's plot the points. So it's 6 is 0, 2 is 1, 0.6 is 2.01. And it will look something like this. Oops. And the 18 is over there. Okay, so that's how the graph is going to look with all the transformation. So if I may, the domain for this one, as you can see, the C, well, the horizontal translation is 0. So therefore, x can be any real number. such that x is greater than 0. And for range, for logarithmic function, it's always y can be any real number.